Okay, now we move on to the capital budgeting technique. So basically we have two types of techniques. Number one is non-discounted cash flow method and the other one is discounted cash flow method. What is the difference between the two is they consider the time value of money or timing of return, and the other one is not consider the timing of return or time value of money. For the non-discounted cash flow method, it does not consider the timing of return or time value of money. We have two. Number one is payback period and the other one is the accounting rate of return. And for the discounted cash flow method, so this one, we are going to consider the timing of return or time value of money. So we have 5 methods over here. Number one is discounted payback period. Number two is net present value. Number three is profitability index. Number four, internal rate of return. And last one is modified rate of return. Alright, payback period. So payback period, we are going to measure how quickly the firms can recover its initial outlay. So it refers to the number of years needed for a project to return its initial investment. So what we are going to consider here, how long it takes that the company will get back the money that they contribute, that they pay at the beginning. So the formula of the payback period equals to initial outlay divided by annual cash flow. So we are going to accept the project if the payback period is less than or equal the firm's maximum desired payback period. For example, if the project is for 5 years and the company desired payback period is 4 years, and you have to consider the project or take the project if the payback period is less than 4 years. Okay, have a look on the example 13 over here. So a firm is evaluating a project with an initial outlay of 200,000. So the project is expected to generate 60,000 every year for the next 5 years. So determine the payback period of the project. So basically the initial outlay that contribute the company is 200k. So what is the return for the company is 60,000 every year for 5 years. So how are we going to calculate for the payback period is we take the initial outlay and then we divide by the annual cash flow. So 200,000 divided by 60,000. So we get 3.33 years or 3 years and 4 months. So you can use this formula if the return of the company or the project return is constant every year. Alright, now we move on to example 14. Alright, so so this is the initial outlay 500,000, but we have the differential cash flow from year 1 to year 5. So year 1 to year 3 will be 150,000 and year 4 to year 5 is 200,000. So how are we going to calculate for the payback period? So have a look here. So in the solution state that here, so for the differential cash flow, so how to calculate for the payback period? So it's not going to be straightforward or same as the example 13. So what we have to do now is we have to calculate for the cash inflows for the 3 years. Alright, so here year 1 to year 3, so 150k. So this is the 150k from year 1 to year 3 is 450,000, and our initial outlay is actually 500,000. So we need the 500,000 to recover our initial outlay, so we still need the 50,000. So how to get the 50,000? The initial outlay had 500,000 minus with the 450,000 for the cash inflows. So this one we're going to get in the year 4. Since the total cash flow in year 4 is 200,000, so we need to apportion the 50,000 to the 200,000. So we take the 50,000 divided by 200,000, we get 0.25 years. So previously we already have 3 years, and plus with 0.25 years now become 3.25 years. But so if some of us still do not understand, so we can look the table over here. So this is the cash inflows, 150 K for year 1, year 2 and year 3, and year 4 is 200,000. So this is the accumulated cash flow. So it means that year 1 is 150,000, and then plus with year 2 it becomes 300,000, and plus with the year 3 now become 450,000. So if the 450,000 we plus with 200k, so for the year 4 is going to be 650,000, but our initial outlay is only 500,000. So the difference, the 50,000 will be paid in the year year 4. So here the 50,000. So the 500,000 minus with the 400,000, 450,000 divide by 200,000. So we can still get the 3.25 years. Alright, now we move on to the advantages of the payback period. So this is the advantages and disadvantages of the payback period. So this is the method that commonly used or popular used by the firm. So number one, our advantage of using this method is it is the simplicity in its calculation and easy to understood by the most people. And then number two, it's going to stress on the earlier return. Why we need the return or cover our initial outlay as soon as possible. Alright, so this is why it's often used as an initial screening process by the firm to eliminate the investment proposals where returns do not materialize until a year later. So it focuses on the earlier returns. Alright, number three, it reflects the true timing of benefit and cost involved in the capital budgeting project by using cash flows and not accounting profit. So this one is refers to the cash flows. So what are the disadvantages of payback period? Number one, it ignore the timing of return. Number two, it ignore the cash that we receive after the payback period because we focus until we get back our initial outlay or our capital that we paid at the beginning. So it is a biased project for the long-term one because the project will normally have return at the initial outlay much later. So some of the project, the return will be at the end and not at the beginning. Alright, so for the example 15, you may do by yourself. Alright, now we move on to the other technique, accounting rate of return or AROR. Alright, so what we are going to do here, we are going to compare the average after tax profit generated by the capital project with the average size of the investment required. So our formula is going to average accounting profit, so we divide by average investment. So we are going to accept the project if the accounting rate of return is actually higher or equal to the firm's maximum acceptable accounting rate of return. So it means that if the project return of the accounting rate of return is higher than the firm's acceptable AROR, then we are going to accept for the project. Okay, have a look here. So this is the formula. So average accounting profit divided by the average investment. So how to get the average accounting profit? So we have to total the after-tax accounting profit for n years, or refers to the number of years that they have in the project. Then we divide by number of n. So it means that we would like to get the average accounting profit. And then we divide by average investment, which is the initial and the beginning. So we divide by 2, or the initial outlay we plus with the expected salvage value, and we divide by 2. Okay, have a look on the example 16. So our initial investment is 50,000 and our expected salvage value will be 5,000, and our useful life is 5 years. So the profit, so increase in profit after tax. So after tax profit for year 1 to year 5 is this one. So this one, it refers to the after tax profit. So year 1 is 2005, year 2 2005, year 3 3000, year 4 3005, and year 5 is 4000. So the first thing what you have to calculate is the average accounting profit. So what we have to do, we have to plus all these, the 5 years of the profit. So this one we divide by 5 years. Why 5 years? We would like to get for the average. So the average profit for the 5 years will be 3,100. So we have to calculate for our average investment. We take the initial outlay and the salvage value, 50,000 plus 5,000, we divide by 2, now we get 27,500. So what is the accounting rate of return? 3,100 is the average profit for the 5 years. We divide by the average investment, which is beginning and ending, divide by 2. So now we get 11.27%. So based on this method, we will accept the project if the accounting rate of return is higher or equal to the firm's minimum acceptable rate of return. So what are the advantages of accounting rate of return? Number one is users accounting profit. Okay, so it's going to be familiar terms. It's not used the cash inflows, it used the accounting profit. So number two, accounting profit is easily accessible and is understood by most of us today. Alright, so what are the advantages of the accounting rate of return? Number one, it does not use the cash flows and therefore it does not reflect the timing of benefit or timing of return for the proposed project. And number two is also ignores the time value of money concept because it gives equal weight to the all return that occur within a project's life. Okay, now we move on to the discounted cash flow, net present value. So what is net present value? We would like to find the difference between the present value of the project's annual after-tax incremental cash flow and its initial investment. So the formula is initial outlay minus present value. So we are going to accept a project if the NPV is higher or equal to 0. So if the project is NPV is positive or higher than 0, so it means that the company already has the extra money. Right, now we are going to have a look on the example 18. So based on the following, after tax cash flows, calculate the NPV project. So it's stated here, initial outlay 400,000. And then annual differential cash flows is 130k, and we already receive our terminal cash flows is 60,000. So assume the new machine will have a 10-year useful life and the company requires a minimum return of 15% should the company accept the project. So now we are going to calculate for the net present value. So for the year 0 will be, this is our initial outlay 400,000. We should bracket because this is the amount that we spent or paid for at the beginning. And then the minimum return is 15%, so we use the 15% over here. So the year 0 is 1 because at the current condition, so discounted cash flow will be negative 400k. And then so this is the project for 10 years useful life. So year 1 to year 10, it will receive 130,000 every year. And then we are going to times with the present value annuity table. So we are going to use the present value annuity interest factor because year 1 until year 10 is actually the same figure we are going to receive. So we create the annuity table. So present value annuity table will give us 5.0188. So we times with 130k. So we are going to receive 652,444. And at the end of year 10 or at the terminal cash flow, so we can get 60,000. So this one you have to refer to the present value only for a single table, alright, because it arrives only at year 10. So you times with 60, so it's get 14,832. So when we minus and plus and this one, so this one will give 276. So it means that the NPV is positive. So it shows that if they implement this project, so the company will have extra money of 267,276 ringgit. So since the NPV project is positive, so the company should accept the project. By accepting it, the value of the company and hence the shareholders' wealth will increase by 267,276. Right, now we move on to the example 19. So example 19 is same like before, but in this situation, you may do it by yourself. So this one will give the negative NPV. So in this situation, if the project give you the negative NPV, so it means that the company should reject the project because the shareholders' wealth will reduce by 116,824. So the advantages of NPV are number one, uses cash flow and therefore able to reflect the true timing of the cash flow involved. It will reflect the timing of return. Alright, number two, it uses the time value of money concept to compare the benefits and costs of the project. So earlier returns are always preferred than later return, and therefore a higher weight will be assigned to those return. Right? So number three, it allows the company to know the exact impact of the project on the firm's value. So we can see if the project is a positive of this figure, so it means that we can know the value of the shareholders will increase by that figure. A positive, the positive of NPV project will increase the value of the firm by the same amount. So this consistent with the goal of the firm to maximize the shareholders' wealth. So there are two disadvantages here of the net present value. So number one, in order to calculate the NPV, so what we have to do is to make sure that they can forecast for the long-term future cash flow. So we need that figure in order to calculate for the net present value. And then number two, we also need to determine the discount rate to be used, and hence it is time consuming. Alright, so it's very difficult for us to calculate for determine the discount rate for the future period. Alright, now we move on to the internal rate of return. So what is the internal rate of return? Is that equates the initial outlay and the present value of the future net cash inflows. So the rate of return that will make the NPV equals to 0. So this one, sometimes it depends on situation. We have to use the try and error to derive the IRR. So these are the steps that we have to follow. So number one, based on the NPV earlier, so either positive or negative. So we have to decide on the future or the next calculation. Alright, let's say it's positive, so it means that the company has an extra money. So the IRR should be higher than the rate computed in the NPV. Alright, so if you get positive, then we should higher rate. So pick a discount rate at a random until you get 0 or negative NPV. So it means that here you have to calculate number one, positive NPV, and the other one you should calculate until you get negative NPV. If still get positive NPV, so need to increase the discount rate and vice versa. Alright, so you will get a range of IRR between the positive and negative NPV. So please make sure that when you calculate, one should be positive, the other one should be negative. So determine the exact IRR, so we need to do the interpolation. So how to calculate for the interpolation? The positive NPV rate, and then we calculate for the positive NPV-RM. So then total positive NPV, and then we minus with negative RM over here. So it's going to be positive, right? Minus and my negative will become positive. And then the higher rate less with the lower rate. So we should accept a project if the IRR is higher or equal to the firm's required rate of return or the firm cost of capital. So it means that if we get the IRR is higher than the cost of capital, then we can accept the project. Alright, have a look on the internal rate of return. So we have three examples over here. For the example 20 here, we can see here. So this project, initial outlay of 5,000, and then it's going to generate 6,000 after 1 year. So how are you going to calculate for the IRR? So NPV equals to 0. So this one is quite simple. Equals to negative 5,000. This is for the initial outlay. And then plus with the 6,000 for the receive, and then divide by 1 plus R. So after we reverse the formula, so we can get R equals to 20%. Right, so this one is very simple. All right, for the example 21 also, for example 21, so this one refers to the initial outlay of 10,000, but this one it will give you generate an annuity cash flow. So it means that the cash flow that you receive every year is the same. All right, so it means that, for example, inflows here 3,500 for 4 years. So from year 1 until year 4, they are going to receive the same cash inflow, which is 3,500. So we can use this kind of formula. So initial outlay 10,000, and then divide by annuity 3,500. So you can get 2.8571. So from here, from year 4 at the table, you look at the value of 2.8571 in the present value annuity. Why the present value annuity? Because 3,500 just now is the annuity that you are going to receive. So you look inside the table of the annuity table, and then you refer row n equals to 4, and then you find the closest figure to the 2.8550, which is in the column of 15%. So the IRR for the project is actually 15%. Right, for the example 22, so a company is considering a project requiring an initial outlay of 17,292, which will generate the following uneven cash flow. So if the question is uneven cash flow, so we cannot use example 20 and 21 to find for the IRR. So a little bit difficult for us to calculate. So what we have to do, number 1, pick a discount rate random. So use the discount rate to calculate the present value of the cash flows, right? So compare your answer with the initial outlay of the project. If they are equal, so the NPV is 0, then this discount rate is the IRR of the project. So if the NPV equals to 0, so the discount rate is actually the IRR. However, if the present value is higher than initial outlay, so it means that you have the extra money than the company, so the present value is higher, so you should increase the discount rate. Okay, so if the positive, so the NPV is positive, then you should take the higher rate. All right, number 4, calculate the present value of the cash inflows and compare again with the initial outlay in step 2. So now have a look on the solution. All right, let's say if we try 12%, our cash inflows is 5,000 year 1, 8,000 year 2, and 10,000 year 10, and then we times with the present value table. This is not annuity because this is uneven. So year 1 cash flows, you times with the present value, so you get 4464, and then year 2 8,000, so you times with 0.7927972, you will get 6377.6. And year 3, 10,000 times with 0.7118 will give you 7118.00. So, and then we minus with our initial outlay, so we'll give the positive NPV, which is 668.10. Since the NPV is positive, we should try the other one should be, you should higher than 12%, because if you use 12%, it will give us the positive value. Now we should try higher, for example 16%. We do the same thing, this one, but this one we change to 16%. So this one will give you this one minus with the initial outlay, and the NPV will be negative. So with the 60%, the NPV project is negative. So as we know, the IRR is actually between the 12% and the 16%. So now we can do our interpolation. So IRR, so we take the positive percentage, and then we take the positive value, and then positive value minus with negative value or plus. After we minus and negative, it become plus, and then this is the highest value minus with the lowest value. So 12% plus with 2.06 will give you the IRR is 14.06. Alright, if we have the conflict between the NPV and IRR, so this conflict will happen when the project are mutually exclusive. It means that if we accept project A, we have to reject project B, or if we accept project B, we have to reject project A. And the other one is the cash flow patterns are non-conventional. So now we are going to have a look on the example. So here, mutually exclusive project, when a project is larger in size and the other than the other, so NPV will be higher. However, it may have a lower IRR than a smaller project. For example, for project A, NPV is 50,000 and the IRR is 12%. And for the project B, is the NPV is less, which is 10,000, but the IRR is higher. So it means that the information between the NPV here and the IRR is the conflict. If we receive the NPV is higher and IRR is higher, then it's okay, no conflict. But now in this situation, A, the NPV is higher, but for B is IRR is higher. So if we have the conflict like this, so what suppose we do is, so in this example, the solution is quite straightforward. We normally prefer more wealth to a higher IRR. So it means that more wealth here, we are going to choose the highest NPV. So therefore, in this case, we should choose project A. The differences between the NPV and IRR is IRR will assume all the cash inflows from a project can be reinvested at the IRR of the project. And for the NPV assumes that the future cash flows from each project will earn the rate of return equal to the firm's cost of capital when they are reinvested. Right now we move on to the advantages of IRR. So the advantage of IRR, number one, uses cash flow and again is able to reflect the true timing of the benefit and cost involved with a project. Alright, number two, it applies time value of money concept and therefore allow comparison of project cash flows in a logical manner. And number three, IRR is very much related to NPV and usually leads to identical decisions. And lastly, number four, it is easily understood as it stresses the rate of return of a project earns. And there are a few advantages here. Right, number one, this method is tedious and time consuming as it normally requires us to use a try and error in order to determine IRR. And number two, it may result in a wrong decision in the case of mutually exclusive project. Alright, next we move on to the other method, modify internal rate of return. So discount rate that equates the present value of the project annual cash outlays with the present value of the project's terminal value. So where the terminal value is defined as the sum of the future value of the project free cash flows compounded to the project termination at the project's required rate of return. So we are going to calculate the present value or the future value at the terminal value. So MIRR assume that all free cash flows over the life of the project are reinvested at the required rate of return until the termination of the project. So there are three steps in order to calculate. Number one, so determine the present value of the project free cash outflow. Number two, we have to determine the terminal value of the project's free cash inflows, right? And then to do this, we use the project required rate of return to calculate the future value of the project's cash inflows at the termination of the project. So we are going to calculate the future value at the termination date. Alright, number 3, determine the discount rate that equates the present value of the terminal value and the present value of the project cash outflows. So if MIR is more or equal to the required rate of return, so we are going to accept the project. But if the MIR is less than required rate of return, so we are going to reject the project. So have a look on the illustration 1. So Langit Biru Company is considering a project with the expected useful life of 3 years. So the after-tax cash flows are as follows. So the initial outlay, 10,000. So the year 1 for the cash inflows, 4,000. Year 2, 5,000. And year 3 is, so the company's required rate of return is 12%. So how are we going to calculate for the MIRR? So if we look over here, so we have to determine the present value of the project cash outflow. So in this situation, for example, at year 0, so you have the outflow of 10,000. And then number 2, we have to determine the terminal value of the cash inflows, right? So the cash inflow, so this one you can use the 4,000 times with 1.1 to the power of 2, or you can use the future value table, all right, for a single. So this one 5,000 and 6,000. So 6,000, if we look back here, the 6,000 is we are going to use for the current year. So this one go to this one will be 1 year, and year 1 to the year 3 is going to be for 2 years. Okay. Alright, so here either you can use the table or you can use the formula. So step 3, so this is the initial outlay of the 10,000 equal to our future value 16617.6, and then divide by 1 plus MIR by the power of 3. So after we reverse the formula, we do this. So this one will get 18.45. Okay, now have a look on the illustration 2. ESM is considering building a new plant. So this project requires an initial outlay of 6,000 and the following cash inflows. Year 1, 2,000. Year 2, 3,000. Year 3, 4,000. And then the required rough return is 10%. So calculate the MIRR. So according to the solution here, so it means that year 0 will be negative 6,000, year 1 2,000, year 2 3,000, year 3 will be 4,000. So what we have to do is to identify the future value at the terminal. So here for the 6,000 is at year 0, so this one, so you have to look at the present value table. So this one, alright, look at the percentage. Alright, so the percentage here is 10%. Okay, so 10% from year 1 to year 3. So this one look at year 2, and this one 2 to year 3. So you look at year 1. So this one is going to be year 0. Alright, so after you take the, for example here, 2,000 times with 1.2100 will give you 2420. This one 3,000 times with 1.1000 will give you 3,300. This one 4,000 times with 1, so equals to 4,000. So this one will be, if we total up, okay, so it's going to receive 9720. So same as the illustration 1, so 6,000 equals to 9720 divided by 1 plus MIRR, the power of 3. So after we reverse all the formulas, so we can get the MIRR equivalent to 17 0.446, and you also can be derived this figure. Alright, now we move on to discounted payback period. So payback period that we do before this is non-discounted. So this is discounted payback period. So this one will apply time value of money. So this one will measure the number of years required to earn back the initial investment from the discounted cash flow. Previously, we calculate the payback period, but we do not consider the time value of money. So have a look on the illustration. So this illustration, for example, okay, so we are going to refer to the example 14, page 257. So this one, the annual cash flows will be 150, 150, 150 for the first 3 years, and for year 4 and year 5 will be 200,000. But this one we have to use the present value table of a single because every year will be different. So we times with this one will give you the discounted cash flow. Alright, so the 150,000 times with this one will give you 133,935, and then you just do the same until year 5. So the accumulated cash flow, so this one will be 133 plus with this one will give you 253,515 plus with 106,770 will give you 360,285, and then plus with 127,100 will give you 487,385. Alright, and your initial outlay is 500,000. So what you have to do, take the 500,000 minus with 487,385, and then divide by 113480. So this one, where do you get the 4 years here? So it means that here this is the cut-off point that already, and the extra will be here. Okay, so after we do the calculation, we are going to get 4.11 years. Alright, so profitability index is known as benefit cost method. So the present value of the cash flows divided by initial investment. So this one we are going to measure that the project creates per dollar of investment. So what we have to do, accept a project if the profitability index is more or equal to 1. So this is our formula. So we take the present value of future cash flows, we divide by initial investment. Or we can use alternatively, we can use this formula. So PI equals to 1 plus NPV divided by initial investment. So have a look on the example 24. A project costs 1,000 and the present value of the future cash flows equals to 1250. So what is the profitability index? So we take the 1250 for the cash flows, and then we divide by the initial investment, which is 1,000. So this one we get 1.25. Or if you want to use the other formula, this one we take 1 plus 250 divide by 1,000. So it means that 1.25 more than 1, we can accept the project.